First, we add all the dry ingredients into a bowl and mix them together, creating a homogeneous mixture. Next, we crack the eggs and added that as well as melted butter into the homogeneous mixture. Lastly, we added the acidic buttermilk into the mixture, which reacted with the basic baking soda in an acid-base reaction, producing carbon dioxide bubbles which create fluffy and airy pancakes.
By applying energy, in this case heat, we see a chemical reaction occur when the liquid of the pancake batter becomes a solid. At this point, a Maillard reaction occurs. The Maillard reaction gives the pancakes their aroma and golden brown color. When you raise the heat on your pancake mix, the amino acids that make up the proteins begin to chemically bond with carbon and oxygen atoms from sugars, thus giving off the aroma of the pancakes.
Here, we are cracking the eggs to access the protein-rich centers. Whisking the eggs allows for the incorporation of air into the eggs for a light, fluffy final product. Adding the fat of the milk starts to separate the proteins in the egg and helps to prevent overcooking as well as resulting in creamier, smoother eggs.
Before we cook the eggs, we first observe a physical reaction as the butter is put into the hot pan and it melts. Now as we pour in the eggs, we begin to see the chemical reaction with the proteins within. The white of an egg contains a large amount of protein, specifically a type called globular proteins, so called because they have a roughly spherical shape. As we apply heat to the egg, the extra energy causes these proteins to move around more vigorously, colliding with each other and weakening the bonds between the different protein strains. As these bonds become weaker and weaker, their globe-like structures start to unfold and the protein becomes denatured. These denatured strands of protein are then free to make bonds with each other, causing it to coagulate. Thus, overcooking the eggs creates too many of these bonds, so the proteins join together too tightly and you end up with rubbery eggs.
Lastly, we have the bacon. It undergoes both a physical and chemical change. As the meat, myosin muscle fibers are heated, they begin to pull together and the proteins are denatured, which is caused by the extreme heats in the pan. Also, the fat portion of the bacon is then melted into a liquid form, hence the grease in the pan. Second, the chemical change, also known as the Maillard reaction, which is the first oxidation reaction between nitric oxide and myoglobin producing nitric oxide myoglobin, which is a bright red and unstable chemical. Upon heating, the more stable nitric oxide myohemochromogen is formed, thus the browning color.